Calypso nears the island of Jamaica, site of the most varied and luxuriant coral reef system in the Caribbean Sea. The echo sounder indicates the most favorable spot to drop anchor.
20 mètres, pareil à mouiller, hein?
Since man first built boats, reefs have taken their toll of ships and sailors.
Bon, allez, 12 mètres, on va mouiller.
In Calypso's helicopter, Captain Cousteau will survey the topography of the reef. This living reef bears hidden secrets of evolution. Creatures once thought to be extinct have been found alive within the reef. Not until recently have the mysteries of coral reefs been extensively explored.
Corals are neither plants nor rocks. They are societies of living animals. And a coral reef is a community pulsing with life, with predators and prey, seen and unseen. Such exotic creatures of the sea have perpetuated an evolutionary chronicle that can be traced back to a time when there were, as yet, no fish in the sea.
Now, Cousteau and the Calypso team will dive back in time to encounter alive some of the earliest forms known to man. Along Jamaica's northern shoreline, the coral reef is a natural breakwater against the pounding surf. Captain Cousteau returns to Calypso after surveying the surface structure of the reef. Cousteau has selected the area that seems most promising for underwater exploration of the reef's foundation. The divers prepare for an extensive study of the reef, which has an evolutionary history dating back more than 25 million years. Marine biologist Dr. Philip Dustin has been invited by Cousteau to dive with the Calypso team.
The reef has been growing up.
A research associate of the Smithsonian Institution, Dr. Dustin has had extensive diving experience here in the Jamaican reefs. The first dive will focus on the internal structure of a portion of the reef that began growing recently, less than 10,000 years ago.
I will handle one of the underwater cameras myself and share in the excitement of filming this dive. We descend into a deep, tapering coral ravine. The water is very still. On each side, the coral grows in flat, shelf-like layers, and the deeper we go, the narrower is the space between the walls. The inner structure of these walls is made of skeletons, the remains of untold numbers of ancient coral creatures that were literally cemented together to form a solid mass. But every surface is alive with coral, sponges, calcareous algae, and many other creatures. We descend along tier after tier of lattice coral, all fused together, giving the reef stability and strength. These mountains of coral are impressive, but they are even more awesome when one considers the reef grows less than half an inch a year.
There are few reefs in the world where the inner framework is so well exposed.
I don't know if I saw it the same way as you did, but to me there is a shelf at about 100 feet or something like that, going slightly down.
Sloping down.
Then on this shelf, it seems that there are pillars. Here's one, then another one here, and you have the impression that they join at the upper part, and that here, at the upper part, if this is the surface, you have the impression that here it joins in the reef, and that the reef has been constructed on this pillar. That first the pillars were built, and then do you think it's correct?
My impression is the same thing. And when we were deeper, you could see small patches, and then as we came up, the patches grew larger.
And then you have all these valleys in between.
That's right. You get a cave structure.
No, it seems that all the reef is hollow.
Yeah. It would seem as though the reef itself has a very loose framework. It's made of very fragile, thin coral.
Very fragile, thin coral, except for the pillar as well.
And then, the pillar itself is very strong, and then the outside. And then the inside of the caves, that looks as though it's a very extensive tunnel system.
Yeah.
Now the team penetrates a cave to explore the network of tunnels. Sense of direction can become confused here. Power cables become lifelines, potential guides out of this underwater maze.
We commit ourselves to the confining hollows of cracks and crevices, the dusty cellar of the reef. It is like traveling through a prehistoric wilderness. Spread out before us is a geological record of the reef's development. Most reef-building coral species first appeared in the Triassic Age 225 million years ago. They endured even the various ice ages which followed. The coral reef is the oldest and most complex ecosystem on Earth.
Deep within a cave, Dr. Dustin comes upon a species of reef creature until recently thought to be extinct. It is a sclerosponge, which was abundant in primordial reefs. Cut off from light by faster-growing coral, it had to adapt to darkness in order to survive.
modern diving techniques have only begun to make this once hidden world accessible. Since man first took to the sea, coral reefs have inspired poetry and wonder and fear. Both in legend and fact, they have long spelled disaster to seafarers and the ships they sail.
Throughout the Caribbean, reefs have taken their toll. Ships wrecked, driven by storms against concealed mountains of coral. Exposed to the unrelenting surf, they will corrode, crumble, and be digested by the sea. Cousteau leads a team of divers toward a group of ships with gaping wounds, marooned on the edge of a reef. They approach the wreck on the leeward side until the water is too shallow for the Zodiac. Along an exposed reef, the wave energy is particularly high, and shipwrecks are unapproachable. Even on the protected side, the odds against swimmers are formidable. Near the breach, ripped in the port side of the hull, Cousteau, Bernard, and Falco fight the rough current and try to maintain their balance against the overpowering surf. Cousteau will have to try another approach. He leads the others toward the bow of the ship. Here, at least, the huge hulk will provide some protection from the waves and current. The small hole near the bow is jagged and not easily accessible, but they will attempt entry. Bernard manages to get a footing, and then, careful of the sharp edges, eases himself inside. With the hole enlarged, Cousteau, followed by the others, enters the gutted ship. Through a tempest of crushing water, Cousteau fights his way toward a central support beam, his only access to the rest of the ship. Bernard has reached the top. Secured by a rope, it is Cousteau's turn to begin the climb.
We are like mountain climbers, balanced above roaring rapids. Only the heavy crossbeams can be trusted with our weight. Like tightrope walkers, we move toward the foredeck. The wreck is decaying. Caution is essential. What seems like solid metal could crumble at a slight touch. Less than 30 years ago, this was a sturdy cargo ship. Now it is a disintegrating skeleton, a mere ghost of a ship. And soon, like a ghost, it will disappear and become part of the reef.
Now the Cousteau team returns to Calypso to observe the behavior of the creatures that inhabit the Caribbean reefs. The thick tropical foliage along Jamaica's cliff-lined coast is rooted in ancient coral. In prehistoric times, this was an underwater living reef. Now it is a solid mass made of remains of coral, sponges, algae, and other sea creatures which once made it their home. The sediment in these cliffs solidified underwater, trapping the coral within. Bernard Delamotte and Dr. Dustin examine the petrified reef.
Bernard, this is a fossil reef that was formed approximately 125,000 years ago, when sea level was much higher than it is today. In this reef, we can see the same processes that put the reef together as we did underwater. We can pick the corals out. This is Acropora cervicornis, the staghorn corals. This looks like possibly a piece of Porites, which is another. Here's another form. And you can see the coral and then the sediment.
Oh, yeah.
Dammed in behind it.
The same formation exactly what you saw underwater.
Same species, probably the same kind of habitat.
Living specimens of the coral found in the fossil reef. On this shelf of staghorn coral, each branch is made up of thousands of individual polyps. Brain coral is identified by its ridges and valleys, which resemble the convolutions of the human brain. Sea whips with soft, flexible skeletons that dance to the rhythm of the swells. Elk-horned coral, an impressive sculptured giant growing in the shallows of the coral community. As I glide through this coral garden, I know that under the beauty, thousands of species engage in a merciless struggle for life. Only the thin surface of coral is alive. As it grows, it continually builds up beneath it a skeleton of calcium carbonate, the basic building material of the reef. Although the Caribbean reefs comprise less than 65 varieties of coral, they include hundreds of thousands of species of reef-dwelling creatures.
The trumpet fish is a conspicuous member of the reef community. It moves cautiously, defensively, keeping close to the coral, careful not to swim in the open. Its length is its problem. It feeds on small creatures, and in order to hunt successfully, it must catch its victim by surprise. So it tries to arrange itself in such a way that it seems not a fish, but a part of the coral. Hovering head down, the trumpetfish once more simulates a slender branch of coral. Now Cousteau and Dustin descend to the lower reef where giant sponges may be found.
In these quiet waters, huge vase-like sponges seem the products of some ancient potter's wheel, offering refuge and shelter for smaller inhabitants of the reef community. Sponges vary in form and size. Round, flat, or tubular, isolated or in clusters, they are spread throughout the reef. The larger sponges are usually found at 25, 50, or 90 feet. Sponges are among the simplest of multi-celled animals. They have no organs, no mouth or digestive tract, no nervous system. Permeated with canals and chambers, they draw in nutrient-rich water through their sides, and having fed, they pump filtered water up and out of their hollow centers. A single large sponge passes through its body about 2 quarts of water a minute. Sponges are the water conditioners of the reef. Sponges appear to be inactive, but that is an illusion.
Now Dr. Dustin approaches a large sponge to demonstrate the efficiency of its pumping mechanism. Using a hypodermic needle, he injects a small quantity of a harmless green dye into the side of the sponge. The fluorescein dye, carried through the sponge via its inner network of canals, is now being pumped, diffused, back into the sea. Clams and other shellfish are also filter feeders and help ventilate the reef. But sponges are the major water purifiers of the community. Mature sponges live fixed in one place, fastened to rocks, shells, or coral. It was not until the 19th century that scientists were willing to categorize them as animals. A century ago, a naturalist called sponges poor creatures who receive nourishment from any wave that washes past them, who inhale and respire bitter water all their lives. He could have saved his sympathy because at least 500 million years before man appeared on the scene, sponges were flourishing. On the way to the surface, during a long, tedious decompression stop, Cousteau enjoys an encounter with a jellyfish. Jellyfish abound in these waters. They are of the same family as corals. Both are coelentrates. A series of daytime dives has revealed but one dimension of the living reef. Ahead for Cousteau and the Calypso team will be full-scale dives at night, when, under the cover of darkness, creatures unseen by day emerge to transform the life of the reef. Aboard Calypso, a physalia, or man-of-war, is examined by Dr. Dustin and Louis Preslin.
The Portuguese man-of-war, as you know, is a very, very dangerous animal.
Is it?
It is. It's been known even to kill people sometimes.
Really?
Below the sail, which supports the animal on the surface of the water, we have the tentacles.
How long can be those tentacles?
Well, these long tentacles here for this size animal are probably somewhere between 3 to 5 meters long when they're fully extended in the sea. All coelentrates, corals, gorgonians, anemones, physalia, and other jellyfish, they have very, very powerful stinging cells called nematocysts that are in these tentacles, all up and down in here.
What is a nematocyst?
A nematocyst is kind of like a pre-charged harpoon. It's a small organelle of the cell, usually oval in shape, and inside that's preset, loaded, much the way a mousetrap is.
Yes.
When it's triggered, it shoots out and sticks into whatever prey is there.
It was the study of man-of-war stinging cells that led, at the turn of the century, to the discovery of the phenomenon of allergy. For most animals, the quest for food is the prime motivation for aggression. But for fixed animals like coral, competition for space can trigger aggression just as fierce. In preparation for a study of coral aggression, Dr. Dustin and Bernard search for species of coral known to be natural enemies. The coral must be handled carefully in order not to damage the thin layer of living tissue on its surface. The coral is placed in a plastic bag of seawater so that it will survive. Phil Dustin and Bernard bring the coral samples to the Discovery Bay Marine Laboratory in Jamaica. They are met by Dr. Judith Lang, a marine biologist prominent in reef research, who has conducted the first major studies of coral aggression. The coral brought by the Cousteau team will be placed in a laboratory aquarium for a special experiment in coral aggression to be supervised by Dr. Lang.
Well, this is a Mussa ankylosa, and it's a very good coral if you want to do an aggression experiment tonight, because this is one of the two most aggressive corals that we have in Jamaica. And the other one over here is another massive coral called Copophilia, and it is not quite as aggressive, but you can do good experiments with that too.
How do you know that?
Oh, because we have put corals together in the laboratory and also out there on the reef, and we have seen the results of their interactions. And every time this coral gives a beautiful demonstration of what we call aggressiveness, or what some other people call digestive dominance.
At the laboratory, the antagonists are placed together so that they touch. It is only at night, in total darkness, that the interaction between corals occurs. Each coral polyp has retractable feeders called filaments. At night, these thread-like extensions reach out for food. Aggressive corals use them to eat their less aggressive coral neighbors. Cousteau arrives to observe the results of the laboratory experiment. Coral ecology is a comparatively new science, and aggression between corals is a recent discovery. For the first time, this phenomenon will be filmed. Cousteau has arranged for time-lapse photography, using a strobe flash every 40 seconds in complete darkness. Cousteau is welcomed by the lab's acting director, Dr. Jeremy Woodley. The Cousteau samples are in a special aquarium in which they have been placed by Judith Lang. The interaction between the two species of coral has been filmed throughout the night.
And here is your setup.
I'll take.
We are studying the aggression between corals.
I understand you discovered that phenomenon.
Well,
Really?
yes.
Huh?
It was
How did
actually
you find it? How did it happen?
a really intelligent ecologist called Evelyn Hutchinson
Yeah.
asked me if corals ever compete for space on reefs, and I was so ashamed that I didn't know the answer. I came back to Jamaica and put some corals together in an aquarium,
Yeah,
and this is what we found.
it's amazing.
We later discovered that it had already been found by a Frenchman.
Really?
Really?
Oh, I'm surprised. Who is he?
Dubois Catala in Nouméa.
Catala, in Nouvelle-Calédonie.
Yes,
New Caledonia.
yes. He has a
Yes.
picture of it in his book.
Right.
Really. And not only that, but another Frenchman about 50 years before that, working in the Gulf of Aden, said, it must be the corals are doing something to kill each other because the way they're growing together on the reef, that's the only explanation.
What
But
about
he wasn't a diver, and he didn't keep them alive.
Are you sure that the Greeks did not discover
Probably, probably,
They discovered everything.
probably.
it? Well, we always find that somebody has
That's
done
right.
it before in every branch, always. Anyway, we were fascinated by what's going on.
Time-lapse photography of one coral devouring another.
7 hours of aggression revealed in 30 seconds of film. The aggressive Musa angulosa on the left pulsates strenuously as it attacks its victim, the Agaricia on the right. The aggressor expands and contracts as its filaments reach out to digest the living tissue of its neighbor. In this competition for space, the submissive coral will ultimately be killed. Only a skeleton will remain, to be covered over completely by the growing tissue of the aggressor. This is, perhaps, the most striking example of the often hidden struggle for life among the thousands of creatures that live in coral reefs.
At night, the reef undergoes a metamorphosis when, undersea as on land, the night shift emerges.
Bon, oui. Everybody ready to be equipped? Huh? All right.
A full-scale nighttime exploration of the reef is launched.
9, 10, 11. Bon, alors, faut y aller. On connaît pas ce que les gars. Au revoir. Les gars.
Cousteau will be one of the 3 cameramen in this 11-man dive. Just below the dive ladder is a swarm of sea wasps, tiny jellyfish with stinging tentacles. Unlike the sea wasps of the Pacific, these are not killers, but they are a nuisance and inflict painful stings as the divers begin their descent.
Enveloped in darkness, who knows what creatures might take shape within the glow of our lights? The reef we know so well by day, how changed will it be at night?
the divers descend, it appears that the reef at night has been abandoned by its regular inhabitants. Finally, the lights reveal trumpetfish, just as shy as they are in the light of day.
Most of the daytime creatures are asleep, tucked into recessed crevices of the reef. A creature of the night, the basket star. It spreads its lacy, tentacled arms to catch drifting plankton. Under our powerful lights, it recoils and begins crawling like a walking bush to its retreat where it hides during the day. Now a spiny boxfish. When this animal is threatened, it puffs up like a thorny balloon, its sharp needles its only protection. The sleeper lobster is rarely seen except at night. It too seeks escape from the premature daytime created by our lights. A stingray is aroused from its slumber in the sand. At our approach, a white sea urchin loses its balance. A large crab enjoying a late-night feast. Ordinarily, at the approach of man, animals stop feeding. But despite our presence, this crab continues to pick up tasty morsels, then brings them to his mouth, chews and digests them. A small spotted moray eel, a nighttime prowler of the reef. The bristleworm is an unusual kind of predator. Its prey are the coral polyps which blossom at night. The bristleworm feeds at the tip of a staghorn coral branch, where the new polyps are most vulnerable. Worms are among the many predators that impede the growth of the reef. The spiny urchin and the basket star roam at night in the open. During the day, they use the reef only for shelter. We have observed that during the night, different forms of life appear and then withdraw. Their places taken by other nocturnal creatures. The reef is in a constant state of change. The tube worm extends its flower-like gills, taking oxygen and food from the water. They are borers that implant their protective tubes in coral. If disturbed, they retract into their shelter. Day divers have never seen the beauty of blossoming coral, for most polyps open up only at night. A brain coral with polyps fully extended actively feeds on zooplankton and other tiny marine animals. Exposed to light, the polyps will slowly contract, and when touched, the mechanism is accelerated. The Jacques are drawn to a swarm of plankton attracted by our lights. They move in quickly for a substantial feast.
Cousteau encounters a distinctive member of the reef community, a squid. As the divers follow it, it suddenly picks up speed. Trying to avoid the divers, it gradually accelerates its pace. The divers continue to follow the tiny, elusive animal. The squid is a chameleon of the sea that can change its color to camouflage itself. And to confuse pursuers, it puts up a defensive puff of ink. A cephalopod mollusk, the jet-propelled squid is such a swift swimmer that it is called the sea arrow. Ordinarily, it moves about by undulating its delicate, transparent horizontal fin that almost encircles its body. It uses its instantaneous jet propulsion to catch prey or to escape.
The squid's 8 short tentacles, equipped with small suction cups, are used with skill to seize swimming fish and to embrace its mate.
It can hover, swim forward or backward, or turn with amazing agility.
The squid has keen eyesight. Its eyes are amazingly similar to human eyes, but each can be moved independently.
Suddenly, a large school of squid spreads before the divers. Now the divers begin their ascent. It had been hoped that the bothersome sea wasps would have been gone upon the divers' return.
Qu'est-ce qu'il y a comme saloperie? Je me suis fait mordre dans l'oreille. C'était une plongée formidable. Ah, vraiment magnifique, un spectacle féerique. Des bites, hein? The mice? Oh, they like our skin. Ah! My ear. Oui. They swim up my arm. Ah! Like little bees.
For the Calypso team, this has been a long and exhausting but exhilarating expedition.
Ça va quand même le strange thing on this part. Ah, and the sight of the light. That was incredible.
Powerful as the Coral Kingdom may be, 4 times over the ages, it underwent dramatic downfalls. And each time, it was reborn with greater diversity and vitality. No ancient reef was ever as rich and beautiful as those we can contemplate today.
Calypso has not escaped a hazard which has plagued sailors since they first took to the sea. Calypso's anchor is wedged in huge coral blocks and cannot be raised. Armed with a crowbar, Bernard Delamotte will try to pry it loose. Cousteau and his team are concerned about damaging the reef.
Once humans lived in relative harmony with the reef. Then gradually they began to ransack its treasures. First, pearl beds were exhausted. Then industrial fishing, spearfishing, coral and shell collecting, pleasure boats dragging anchors and spreading litter depleted the reef population. Next, oil drilling invaded the reef. War inflicted its wounds, as did the testing of atomic weapons. But the devastation must and can be stopped. Coral reefs are as important as the Amazonian rainforest in carrying out the carbon fixing that can counteract the greenhouse effect that causes global warming.
Finally, the anchor is free. And Calypso is on her way.
We leave the reef with an impression of eternal complexity, with puzzlement over its abundance and its variety of shapes. Yet, unfortunately, this empire is vulnerable and at the mercy of humankind. If we were to bring about its collapse, it would probably take 10 or 20 million years to regenerate, long after we ourselves may have disappeared from the earth.